Rational equations. In this lesson, we will learn techniques for solving equations that contain rational expressions. Rational equation is an equation containing rational terms either in the numerator or in the denominator or in both. A rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials. These fractions may be on one or both sides of the equation. A common way to solve this equation is to reduce the fractions to a common denominator and then solve the equality of the numerators. Domain and range of rational function. The domain of a function f of x is the set of all values for which the function is defined, and the range of the function is the set of all values that f takes. A rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomials, and q of x is not equal to 0. For example, f of x is equal to x squared plus 5 over x plus 2. Note, the numerator and denominator have no common factor and the denominator cannot be 0. For example, find the domain. To find the excluded value in the domain of the function x squared plus 2 over x squared plus 6x plus 8, first, set the denominator to 0, and we get x squared plus 6x plus 8 is equal to 0. Then, factor out, and we have x plus 2 times x plus 4 is equal to 0. And solve for x. X plus 2 is equal to 0. So x is equal to negative 2. And x plus 4 is equal to 0. So x is equal to negative 4. Therefore, the domain of the equation is the set of all real numbers x such that x is not equal to negative 2 and x is not equal to negative 4. Next example, find the domain. Again, to find the excluded value in the domain of the function f of x is equal to x over 2x minus 4, first, set the denominator to 0, and we get 2x minus 4 is equal to 0. Then, solve for x, and we have 2x is equal to 4. Then, divide both sides by 2, and cancel out the common term, which is 2, so x is equal to positive 2. Therefore, the domain of the equation is the set of all real numbers x such that x is not equal to positive 2. Next, find the range. If you have the function f of x is equal to x plus 1 over 3x plus 2, to get the range, first, rewrite the equation by changing f of x to y. And we get y is equal to x plus 1 over 3x plus 2. Next, cross multiply. Then, distribute y. We have y times 3x plus 2 is equal to x plus 1. and simplify. Y times 3x is equal to 3xy. Y times 2 is equal to 2y. Then, group x. We have 3xy minus x is equal to negative 2y plus 1. After group x, factor out x. We have x times 3y minus 1 is equal to negative 2y plus 1. Then, divide both sides by 3y minus 1. Cancel out the common term, which is 3y minus 1. So, x is equal to negative 2y plus 1 over 3y minus 1. After getting the value of x, next, equate the denominator to 0, and we get 3y minus 1 is equal to 0. Then, solve for y. We have 3y is equal to 1. Then, divide both sides by 3. Then, cancel out the common term, which is 3. So, y is equal to 1 over 3. Therefore, the range of the equation is the set of all possible values of y is given by negative infinity to positive 1 over 3 union positive 1 over 3 to positive infinity. Intercepts are points at which a graph crosses either x or y axis. X-intercept, where the graph crosses the x-axis. The x-intercept of a function is the x-coordinate of the point where the function crosses the x-axis. Since the function can cross the x-axis multiple times, it can have multiple x-intercepts. The values of x-intercepts of y is equal to f of x can be obtained by setting f of x is equal to 0. Y-intercept, where the graph crosses the y-axis. The y-intercept of a function is the y-coordinate of the point where the function crosses the y-axis. The value of the y-intercept of y is equal to f of x is numerically equal to f of 0. A function can have at most one y-intercept as it can have at most one value of f of 0. For example, to find y-intercepts, set x is equal to 0, then solve for y. And to find x-intercepts, set y is equal to 0, then solve for x. Find x and y intercepts. If you have the function f of x is equal to x plus 5 over x minus 3, for x-intercepts, first, substitute 0 for f of x, and we get 0 is equal to x plus 5 over x minus 3. Next, cross multiply. Then, simplify. We have 0 is equal to x plus 5. Negative 5 is equal to x. And x is equal to negative 5. So, the x-intercept is at negative 5 and 0. And for y-intercepts, Substitute 0 for all x, and we get f of x is equal to 0 plus 5 over 0 minus 3. Then, simplify. We have y is equal to 5 over negative 3, and y is equal to negative 5 over 3. So, the y-intercept is at negative 5 and negative 5 over 3. Next, find x and y intercepts if we have the function f of x is equal to 5x minus 3 over 2x. For x-intercepts, first, substitute 0 for f of x, and we get 0 is equal to 5x minus 3 over 2x. Then, cross multiply. So we have 0 is equal to 5x minus 3. Then, solve for x. We have 3 is equal to 5x. Then, divide both sides by 5 and cancel out the common term, which is 5. And x is equal to 3 over 5. So, the x-intercept is at 3 over 5 and 0. Again, using the function f of x is equal to 5x minus 3 over 2x, for y-intercepts, substitute 0 for x, and we get f of x is equal to 5 times 0 minus 3 over 2 times 0. Then, simplify. So we have y is equal to negative 3 over 0. As you can see, this function never crosses the y-axis because since you cannot divide by 0, it is undefined. In fact, anytime a function is undefined at 0, it will have no y-intercept. Take note, if the denominator is 0, there is no y-intercept. Zeros of a polynomial function is a number that solves the equation f of x is equal to 0. These numbers are also referred to as roots or solutions. For example, the zeros of a function are the collection of x values where the height of the function is 0. Find the zeros of the equation. When finding the zeros of rational equation, zeros are also known as x-intercepts, solutions, or roots of functions. They are the x value where the height of the function is 0. For rational functions, you need to set the numerator of the function equal to 0 and solve for the possible x values. If a whole occurs on the x value, then it is not considered a 0 because the function is not truly defined at that point. For example, if you have the equation f of x is equal to x squared plus 3x plus 2 over x plus 2. By using the factoring method, first, factor out the term which is factorable, and we get f of x is equal to x plus 2 times x plus 1 over x plus 2. Then, multiply both sides by x plus 2. Take note, f of x is equal to 0. So we have 0 is equal to x plus 2 times x plus 1. Then, equate to 0, we have x plus 2 is equal to 0 and x plus 1 is equal to 0. Then, solve for x, so x is equal to negative 2 and x is equal to negative 1. Therefore, the zeros of the equation are x is equal to negative 2 and x is equal to negative 1. Next, method 2, using the long division method, is another way to find the zeros of the rational equation. For example, x plus 2 divide x squared plus 3x plus 2. First, x squared divide x is equal to x. X times x is equal to x squared. X times 2 is equal to 2x. X squared minus x squared cancel. 3x minus 2x is equal to x. Bring down 2. Then, x divide x is equal to 1. 1 times x is equal to x. 1 times 2 is equal to 2. X minus x cancel. 2 minus 2 cancel. Remainder 0. Therefore, the zeros of this equation are x plus 1 and x plus 2. Note, to get the zeros of the rational equation, the remainder must be 0, otherwise, there is no x-intercepts. Next, equate to 0. We have x plus 2 is equal to 0 and x plus 1 is equal to 0. Then, solve for the value of x. We have x is equal to negative 2 and x is equal to negative 1. Therefore, the zeros of the equation are x is equal to negative 2 and x is equal to negative 1. And the last example, method 3, using the synthetic division, is another way to find the zeros of the rational equation. For example, negative 2 is the divisor. Divide to the coefficients of dividend, which are 1, 3, and 2. Now, bring down the leading coefficient, which is 1. Then, 1 times negative 2 is equal to negative 2. 3 plus negative 2 is equal to 1. 1 times negative 2 is equal to negative 2. 2 plus negative 2 is equal to 0. So we have 1x and 1. So the answer is x plus 1. Since the assumed divisor is x plus 2, and the answer from the synthetic division is x plus 1, therefore, the zeros of the equation are x is equal to negative 2 and x is equal to negative 1. And that's all for the rational equation. Thank you.